I think most of you have already started on the graphing. I haven't spent all much time devoted to it because you guys know how to do the basic ones. You know what they look like. We did them like right at the beginning because you know normal trig functions, right? But they can be changed in a few different ways, and they're all ways that you're familiar with already. So that's why I haven't devoted all that much time to it. I think on your own steam, you'll be able to work out what they look like. But I just want to go through it methodically so that you know there's a couple of tips and tricks to help you do this well. And then I think that's basically it. Like, there's nothing else on the inverse trig. You guys have covered it all, which gives us some time to revise, do past papers, and so on. Okay.
Is this the last
This is the last thing for the exam.
Well, yeah. So the big topics were integration and areas under curves and inverse trig, including old, special trig stuff from before, auxiliary angle, general solution, and so on. There is corner geometry proofs, which is actually the first topic, which I kind of skipped over, because I thought you guys could do that kind of on your own in this revision time, rather than me wasting time at the beginning of the term sort of teaching you the stuff which you already know. Okay?
At the beginning of the term, didn't we do ratios of some topic? I can't remember.
So that'll come under corner geometry.
Was
Yeah.
that one again?
So I didn't devote any time to it, even though it's there in the program, because I think you guys, you learnt it like a year and a half ago. So yeah, I think you guys can cover that on your own. But you've got the program, have a flick through it. That's what these next couple of weeks are for, yeah.
So what I mean by assessment is just going to be like trig min, like integration.
No, I would say it'd be equal parts trig and integration. They're both huge topics. There's lots of different kinds of questions that come up a lot under integration. Right? We can do definite integrals, we can do indefinite ones, we can do Simpsons and trapezoidal and volumes and so on. Okay, I can basically guarantee, if you remember from the end of year 10, you know when you did your topic tests on those 4 topics, right? And they were kind of different to an exam, because in an exam you're like, oh, I'll study these kinds of things, and then you'll get a question on this one and this one and this one. Because we can't possibly write an exam which literally tests everything. But a topic test is, okay, look at all of these skills, we're going to test all of them. We give you, you've got a graph, you've got to do the area of a shape, you've got to do and so on, right? Integration's going to be like that in this exam, okay? Because every aspect under integration, there are no kind of weird side sort of not very common pieces. Every part of integration is dealt with a lot. So, mine actually.
How's the boots?
you've got Justin.
Yeah, I try to see
That's
that.
a video.
Yay!
Yes! Everyone disliked the video.
Shout out to Justin. Okay, now anyway, let's therefore have a look at graphing trig functions, and then we'll be done. Okay. Now, if you remember, transformations means you take something which you know, and then you just twist and turn it a little bit, right? So you have a kind of modified version. Now, there are 3 main kinds of transformations that we're going to cover under inverse trig functions, and you know all of them already. Okay. So the first one, the easiest one, is when you change the scale of a graph. Okay. So you stretch it or you compress it or something like that. Okay. So how would you do that? What might it look like if you would change the scale of, say, sine inverse? Yeah, that's right. Well, actually, all of these are going to be the placing of constants in places. The question is, what places are they? Okay. So, example. Okay. We did this. We looked at that and the integral that turns into that, right? So if a is a constant, like say 2. Okay. This is going to be a horizontal change in the scale. Okay. And obviously, if I changed, if I put a 3 there, that would also change, but it'd be vertical. Okay. So there's scale changes. You can also change the position or shift the graph elsewhere. Okay. So how might we do that? If we wanted to shift it horizontally, say 1 unit, how would we do that? Just from regular sine inverse. Yeah, good. So x minus 1, if you remember this, so it's backwards, right? So this is going to go to the right, 1 unit. By extension, if I wrote, we tend to see it over here, for instance. Actually, probably be an angle, something like this. Okay. That would have the effect of pushing it up, pi on 2 units, radians. I'm going to suggest that it's going to be more helpful to us to actually write it like that, but we'll get to examples in a second. Okay, but that's doing the same thing. It's the same sine inverse graph, but now put it in a different spot. Okay, and there's one, bless you, main other kind of transformation that comes up. Can anyone remember what it is? Now, it's sort of like I suppose, you know, if you think about these,
If you make it negative inside the graph.
this is phase, right? When you think about original Trig graphs, this is phase. This is both period and amplitude, depending on whether you change y or x. What's left? Yeah, good. So we can reflect, right? Or flip the graph, okay? So how would you, if I wanted to take sine inverse and turn it back to front, that way, left to right, how would I change that? How would I do it?
Y equals sine inverse of negative.
Good. So you're starting to get the sense, right? Whichever variable, x or y, you slap the constant or variable or whatever on, that's what you're going to modify. So that's why this is a horizontal flip. And this would be a vertical flip. Okay. So you got to be careful. It does make a difference, right?
Wait, when with sine inverse, I put the minus on.
Okay, so the sine inverse is an odd function, right? So yes, you can. So in this case, a horizontal flip and a vertical flip are the same,
Oh yeah,
right? Right? Yeah, they're the same. So, but obviously with cos, that would not be the case. Okay. Tan inverse, since it's also an odd function, vertical and horizontal would be the same. Okay, so let's just quickly do some examples. Let's just draw sine inverse first. Okay, just standard old sine inverse. Oh, that's pretty bad. There we go. Okay, now, like I said, I haven't devoted a whole bunch of time to this, but you guys know by now, you're going to have to put points on this to state, you know, your beginning and end of domain and the beginning and end of your range. Okay, so let's do that. Now, if that's what regular old sine inverse looks like, okay, let's start to change it a little bit. We'll start to go through some of these. And what's the best way to actually, number one, work out your graph? And number two, which is just as common, work out what the domain and range are, okay? So for instance, I'll just block this up over here. If what I now asked you to graph was y equals 2 sine inverse of x on 3, okay? Now, there's a couple of different ways to think about this, right? You can think about it as, oh, it should be twice as high, right? You're stretching it out, that kind of thing. I think the most methodical way to do it is to make sure wherever the constant is, it should be together with whatever it's modifying, right? So this 2 is not really modifying this. It's actually changing the y, right? The 2 applies to the y. So that's why it's a vertical thing, okay? In the same way, I mean, it's kind of obvious because it can't go anywhere else. This 3 is modifying the x. Now it's crucial to get it into this kind of form because now I can write out my domain and range, okay? Now, coming back to the original, right? Hopefully we're familiar with this enough. That the domain here is -1 to 1, right? And my range is minus pi on 2 to pi on 2, okay? So now that I have not y, but y on 2, and not x, but x on 3, I'm going to put each of these wherever the corresponding x's and y's were, right? So for example, if I'm working out domain, instead of writing x is from -1 to 1, I should write x on 3 is from -1 to 1, okay? Okay? So now if I want to work out the actual domain, which is for x, right, I multiply through by 3, right? -3 to 3. Okay. Now, often, see, this is the error that people make, and it's a common one, and I used to do it myself, is you start from the domain you're used to. You're like -1 to 1, and then you're like, oh, but I have an x on 3 and not an x. So you're like, okay, I'll divide through. And then you wonder why it kind of, you're like, huh? Which one is it, okay? So you want to make sure you avoid doing this. You see, this only applies to the original graph, right? Now that I've changed the variable, okay, it's not an x in there anymore. So that's why my inequality changes. Okay. So avoid that. Do the same thing for y. So I have y on 2, sorry, y on 2 in the middle. And I'm between minus pi on 2 and pi on 2. So you can see, you know, even if you thought about it before as, okay, now I'm twice as high, right? That's why you're going from minus pi to pi. Okay, so Far out. Okay, now that I have all my domain and range, okay, I'm going to use that to draw my graph. Now, I think it's actually really helpful to do this first, right? Rather than actually start thinking, okay, where am I going to put this? Because that'll mean that when you put a scale on there, it'll actually be, easier to draw rather than harder to draw. Okay. Now, since there's no horizontal or vertical shift, it's going to look exactly the same as this, right? It's just that my labels will be different. So I'm just going to draw the same graph. Okay, but I'll just label my empties differently. Okay. Yeah. Okay. Scale is going to start to get pretty tricky here, okay? Generally we've said before, scale's not that big a deal. We're looking mainly for features, okay? But with all of these graphs, the features are all going to be very, very similar, okay? So they are going to pay attention to scale. Now I'm going to do I'll do a horizontal shift in a minute, and I'll do a horizontal and a vertical shift in a second. And the important things are, you've got to actually have these points. They should be symmetrical around there, right? And this point of inflection should be directly in the middle. And I should be able to look at that coordinate and say, in this case it's easy because it's at the origin. Okay, and so is this. But if it's not at the origin, the point of inflection should be at the right spot. Okay, now you don't need calculus for that. You just need to know it should be halfway. Okay, but if it's off, if your point of inflection is like somewhere up here or somewhere down there rather than bang in the middle, they'll get you for that. Okay, because it's, can you draw it accurately or not? Okay, let's do another one. Let's give that one a go. I'm not going to do this yet. Okay, now, you might have noticed, I was about to start drawing a set of axes, and then I stopped myself, which you should do too. We should go through this process of working out domain and range first, because then you work out which parts of your axis you'll actually need, okay? So domain is all about this part in here, okay? So this is x on 4 plus 1, and that's between minus 1 and 1. Okay? So what's the most natural thing to do first? I guess we would subtract 1 from all of them. So this is going to become minus 2. This is going to become x on 4, and that's 0, okay? And now I multiply through by 4. Okay, so you can see I'm only going to need the left-hand side of the axis. I'm not going to need the positive side. Okay, range. You can tell me right away. What's the range? It's just the regular one, right? Because as I've written it, there's no modification on y. Okay, so it's just what it would be without any changes. Okay, so now let's draw our set of axes, which, as you noticed before, it's just going to be on the left-hand side. Now, because I'm going from 0 to minus 8, right, so 0 to minus 8, what I do want to note is, if that's where minus 8 is, I need to know where minus 4 is, right, because that's where the point of inflection will be. Okay, and if it's not there, if I miss as I'm drawing it, that's a significant feature. Okay, minus pi on 2 and pi on 2, that's fine, so I can put them wherever. Though it's in your interest to make sure it's tall enough, and things are sort of, the closer it is to being square, the easier it is to make sure that, number one, you get to a vertical line up here, and number two, you come through and you can have a nice shape there. Okay, if it's really squashed this way or that way, it's hard to make the features look obvious. Okay, so should end up. There you go.